So we had the SID Display week here at Radiant, and who are you?
I'm James Wheeler.
So what are you showing here?
Sure, this is our two-camera system for essentially measuring OLED devices, right? So we have two cameras because the resolution of these devices is just so high that we're going to need two of our highest resolution photometers to measure this. But essentially we measure one half of the display with each camera, and then we stitch those two images together.
It's very high megapixel, or?
That's right. These both are 29 megapixel each.
And then what's special about those machines right here that you have?
So essentially they're just super high accuracy imaging photometers. So very low noise, so you got a great signal noise ratio, high dynamic range.
What's a photometer compared to like a camera or something?
So essentially just photometer means it's, you can only get brightness information out of it. You can't essentially see what type of color it is. For color you'd want to use an I series, but for the specific application it has to be the Y series.
Are you checking if the AMOLED display is in uniform intensity of brightness?
Exactly. So typically for monochromatic LEDs that's used in the subpixels, due to the manufacturing process, it's very hard to achieve consistent brightness output for each individual subpixel. So what we can do is we can step through with our software, we can measure each half of the display, and then we can have a sequence built up here where we can measure the brightness at each varying gray level for each color, and then from that information with our algorithms we're able to create correction factors that we could push to a manufacturer's display, and then they could essentially level out the display so it looks very uniform to the eye.
So how do they level out? This is OLED, right?
That's right.
The AMOLED smartphone market.
Mm-hmm.
So how do you improve their displays?
Sure.
Is that what you do?
Exactly. So using this kind of system, what we would do is create those, calculate those correction factors, and then we would push that to their display. So however way they have it set up to where they could handle the data that we would give them, they could use those correction factors to then scale each individual subpixel by the appropriate amount, such that to the eye it looks very uniform.
Would they have a machine like this in the factory, or you have this in your headquarters and you just remotely help them?
No, so it'd be in their factory. That'd be a total, complete turnkey solution we provide to the customer.
Do they have to check every single phone, or no? It's just once in a... Like what, for every batch of
sure,
displays?
I mean, it all depends on the customer's needs, but typically that would be something they'd want to do. Ideally, is to check everyone at that along that process.
Nice. Let's walk over here. There's a cool machine around here. What's going on with this machine right here?
Sure. So this is part of our new advanced vision technology that we got going on right now. So essentially, this is just simulating a product assembly line. And so what we're able to do is, as it's continuously moving, we're still able to capture images really quickly. And then from
of the PCB and everything inside?
That's right, yeah. So this is kind of the stage where it's being assembled still.
Is this real production product, like it's out there?
That's right. So, so as you can see from these images, as they go through, we take an image, and then you're able to detect the presence or non-presence, I guess, of certain components, like if they're missing or if they're not in the right position, that kind of thing. So it can automatically detect all these things, like different cables.
Is it kind of AI, an algorithm?
That's right. We have advanced algorithms used to kind of detect each of these components. And with this new platform, you're able to kind of drop in different types of, find certain shapes or find a barcode, that kind of thing.
Nice. So that's your slogan, see the difference. It's a lot about vision, measuring stuff.
Touch all kinds of applications, including, take the shroud off, that's just for the harsh lighting. So we're really trying to branch out to all kinds of different markets. Historically, we've been more into the the typical flat panel display inspection, measuring the brightness and color of those. But recently, with all this new emerging technology for things like augmented reality and virtual reality, we're really trying to create new optics, for instance. So this is our own in-house design for a lens. A lens, that's right, that actually simulates the human eye. So we have an entrance pupil of the lens that's right at the end of the lens, rather than typically in the back, as is normal for regular lenses. But this allows you to get it right in the goggles, so it simulates just like an eye would see. And so you can actually see a field of view out to
And then you can
plus minus 120.
analyze the performance of these VR headsets.
That's right. So we can actually analyze the performance in a fully assembled, complete product, rather than analyzing that at at the lens level, kind of disassembled.
What is this one?
So this one is kind of similar to the OLED demirror solution, the 2-camera solution we just talked about. Specifically, though, we're showcasing this new emerging technology, which is the microLED. Very similar to OLED devices, except they can essentially very tiny LEDs and on a very flexible thin film that are used for backlighting for all kinds of different devices.
So you are ready for the microLED market?
That's right. That's right.
Yeah. And if we walk around a little bit more over here, so these are this one is testing tablets.
Yeah. So unfortunately, right now we're having an issue with the motor to control this turntable. But the whole point of this demo essentially is just to showcase that we're leaders in kind of the whole production process. So we can integrate with a customer's fixtures for like the production line. So we can communicate with the fixture to control things such as automatic loading and unloading of the DUTs, the displays under test, and then based on that we can automatically trigger image acquisition and then running the special analyses that they want to run for qualifying these types of devices.
For tablet kind of devices.
Yeah, exactly. It could be really anything. And this is just kind of highlighting the fact that we're well versed in integrating with these special fixtures.
So how much does it cost one of those cameras? Or they're not cameras, right? But what?
Yeah, they're cameras.
They're cameras.
Yeah, CCD based.
Is there a secret?
That'd probably be a question for a sales guy, but
it's something that factories buy.
That's right. Yeah.
It's not for like reviewers of consumer electronics. Could they be using that to kind of like have numbers on their reviews that says this is a better phone than that one because it has better display?
This is definitely like a scientific grade camera, so it'd be kind of too expensive for the normal
normal people.
Yeah, that's right.
Let's go over here. This is for the HUD.
So for this one, we're measuring an aftermarket heads-up display that you can fix right on top of your dashboard, and then so it has a projected image out a few feet that we're able to actually capture that image and then run special analyses on that as well.
All right.
Yeah, so for instance, you can kind of see too, we have an image right now of the speedometer that it projects out. We're able to capture that, and we can automatically detect each part of that image and run specific analyses on that.
Nice. And here you have sparkle.
So this is another automotive related kind of setup here where based on these anti-glare and anti-reflective coatings that get placed over automotive displays, that really helps to cut out the glare and things, but it causes this, it might be kind of hard to see, but it causes a kind of mottled, we're calling it like a sparkly effect on the front of the panel. So we're able to capture images of these and then run our test to essentially characterize the amount of sparkle that's apparent to the human eye, and then rank these so we can, we really essentially matching up to a human visual inspector to, characterize which DUT is better. Yeah.
Where are you based? The headquarters?
So we're based in Redmond, Washington.
And does the whole display industry, everybody uses Radiant?
Pretty much, we're the world leaders in display inspection, yeah.
World leader. There's another one here.
That's right.
This is a big one.
Yeah, so this is another one of our brand new optics here. So we have a flat panel display conoscope lens. So it's essentially, able to, in one measurement, capture the light emission at all angles up to plus or minus 70 degrees. So rather than traditionally requiring the device to be mounted to a goniometer where we could rotate the display, up to 360 degrees, and then capture the output at all those angles, that can be very time consuming. So this is able to do it in one shot, at least up to plus or minus 70 degrees.
It's a special new lens design.
That's right.
Just for this application.
That's right. It's very high grade. So.
And what's next? Because what's the biggest challenge right now?
So, I mean, this is kind of it. It's just trying to meet the demand of our customers. I mean, there's so much new emerging technology like augmented reality,
microLED.
Exactly. All the new automotive is really kind of exploding with new stuff like the instrument clusters,
Flexible
heads-up
displays.
That's right, flexible ones.
Are you going to be measuring those?
That I guess remains to be seen. So we're still kind of exploring all
Because
of
there's
our
so many
options.
things like the crease, the flex, the
Exactly.
performance of those plastic-based displays that are coming out.
Sure.
There's so much you could be doing, I guess, with the factory automation, right? Stuff.
That's right, and that is kind of the biggest challenge, I guess, is trying to respond to the market changes and being there first with the leading technology that we can offer.
So you have an R&D?
Yeah,
R&D.
that's right.
R&D. What do you do?
So I'm typically more responsible for the software. So for kind of that turntable thing, I'd be more responsible for helping create essentially a custom solution for a customer where they have very specific needs on their fixturing. They need something specific to happen when how they want to control the camera, special results they might want to get out of that. So I'm kind of involved in that process.
And your company is involved in Asia and everywhere.
That's right. Yeah, all over the world. But a lot of market share in Asia. So.